Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this particular video I'm going to solve a question from past papers of A-level Maths P3 Cambridge 9709 May June 2019, paper 3 variant 3, and question number is 2. And this particular question is based on the topic integration, specifically the subtopic integration by parts. And as you can see that we need to show that the value of this integral is pi square minus 8 completely over 32. Okay. And we need to integrate x squared times cos 2x with respect to x with upper limit pi over 4 and the lower limit 0. So as we can see that one term is algebraic and the other one is trigonometric. So what we are going to do, we are going to follow the late rule. Okay, so in order to see what the sequence of u should be, I mean what to take in place of u and what to take in place of v dash. So we will follow the late rule over here. Okay, so a comes first, t comes afterwards. So a is x square and t is basically cos 2x. So u will be taken as x square because the purpose is to make u dash simpler. Okay, so u dash is equals to 2x. And in place of v dash, we are going to take cos 2x so that when we integrate this, we get sine 2x over 2 because when we integrate cos, we get sine x. Okay, when we integrate cos x, we get sine x. So when we integrate cos 2x, this means we get sine 2x completely divided by 2. And as you know, the fact that the question which is based on integration by parts, it is given to you in this form, the integration of uv dash with respect to x, meaning the integrand is given to you in the form of u times v dash. So when you integrate this, you get uv minus integration of vu dash with respect to x. This formula is also given to you in the booklet in the exam. Okay, so uv minus integration of vu dash with respect to x. All right, so u times v, this will give you x square times sine 2x over 2 minus integration of vu dash with respect to x. Okay, so this will be 2x times sine 2x completely over 2. When v and u dash are completely multiplied, you get 2x times sine 2x over 2. And this thing is already integrated. So upper limit pi over 4 and the lower limit 0. And this is supposed to be integrated in the next step. So upper limit pi over 4 and the lower limit 0. Okay, so far we have achieved this thing. Now, as we can see that this 2 and 2 gets cancelled out, eliminated. So this essentially means that x squared times sine 2x, we can also write completely over 2 as well. Okay, this is exactly the same thing. And then minus integration of x times sine 2x with respect to x. So this whole thing is integrated. So upper limit pi over 4 and lower limit 0 over here. And this is supposed to be integrated. So upper limit pi over 4 and then lower limit 0 over here. So far we have achieved this thing. So now what I'm going to do, I'm going to integrate this x times sine 2x with respect to x. Okay, so for that purpose, I'll make a separator over here. Okay, and I'm going to do some working for integrating x times sine 2x with respect to x with upper limit pi over 4 and the lower limit 0. Okay, so again, we use the late rule. Okay, so u is equals to x so that u dash becomes simpler. U dash will be equals to 1 and v dash will be equals to sine 2x. So basically we integrate sine, so we get minus cos. So when we integrate sine 2x with respect to x, we get minus cos 2x completely divided by 2. Okay, so uv minus integration of vu dash with respect to x. So this turns out to be minus x times cos 2x over 2 minus integration of vu dash with respect to x, which is minus cos 2x over 2 itself. Okay, and this thing is integrated. So upper limit pi over 4 and lower limit 0 over here. And this is supposed to be integrated. So upper limit pi over 4 and lower limit 0 over here. So therefore we can say that minus x times cos 2x over 2 plus integration of, what we can do over here is we can take this half as common outside. So taking half as common outside, and we are supposed to integrate cos 2x with respect to x with upper limit pi over 4 and lower limit 0. And here we will write the upper limit pi over 4 and the lower limit 0 like this. All right, so far we have achieved these things. Now we need to just integrate this cos 2x further, and this does not require integration by parts. This is basically the integration of a standard trigonometric function. Okay, so this means minus x cos 2x over 2 plus half times what? Uh, we integrate cos, so we get sine. So when we integrate cos 2x, we get sine 2x completely divided by 2. Okay, so now upper limit pi over 4 and lower limit 0 like this. So this turns out to be minus x times cos 2x over 2 plus sine 2x over 4. Upper limit is pi over 4 and the lower limit is 0. Okay, so far we have achieved this thing. So now I'm going to make a separator over here. All right. So as you know that when we integrated x times sine 2x with respect to x, we got this complete thing. So this essentially means that x squared times sine 2x over 2 minus the integration of x sine 2x with respect to x. And in place of this, we can write minus x cos 2x over 2 plus sine 2x over 4. Upper limit pi over 4 and the lower limit is 0. Okay. So now we are just going to expand this. So x squared times sine 2x over 2 plus x times cos 2x over 2 minus sine 2x over 4. Upper limit is pi over 4 and the lower limit is 0. Okay, so now every integration is now done. Now what we need to do, we need to substitute these upper limit and lower limits respectively. All right, so pi over 4 is squared, pi over 4 is squared multiplied by sine 2 pi over 4 completely divided by 2 plus pi over 4 times cos 2 pi over 4 completely divided by 2. Okay, and then minus sine 2 pi over 4 completely divided by 4. Here we put the upper limit pi over 4 and then subtraction sign, and then we put the lower limit. So this x squared times sine 2x over 2 basically turns out to be 0. And then in place of x, when you put 0, so this also gets 0, and this also turns out to be 0. Okay, so this essentially means that this pi over 4 squared is pi squared over 16 and then divided by 2. So pi squared over 32, pi square over 32, and sine 2 pi over 4 means sine pi over 2, and value of sine pi over 2 is basically 1. So pi square over 32 multiplied by 1. Then pi over 4 is divided by 2, so pi over 8. But cos 2 pi over 4 means cos pi over 2 when 2 pi over 4 is simplified. So this is pi over 2. So cos pi over 2 is basically 0. So this turns out to be 0. And then we subtract what? Sine 2 pi over 4 divided by 4. So sine pi over 2. So sine pi over 2 is basically equals to 1. Okay, so this is, subtracted 1 over 4. So far we have achieved this thing. Okay, so pi square over 32 minus 1 over 4. However, what we need to do, we need to show an exact form over here, which is required in the question. So what we can say that when we take 1 over 32 as common, what we are left with pi square minus, in place of this constant term 1 over 4, we are going to write 8. Okay, basically 1 over 4 is divided by 1 over 32 because 1 over 32 is taken as common. So here we have shown this pi square minus 8 completely multiplied by 1 over 32. This is supposed to be our answer as per the requirement. Okay, so this was a question based on integration by parts from the attempt May-June 2019, paper 3 variant 3. For more videos, follow my YouTube channel. Thanks for watching.